Uh, Welcome everyone to today's lecture. We will be talking about our project on enhancing esports team performance together with my colleague Bram. We are part of the Breda Universities of Applied Sciences located in Breda in the Netherlands, and this is a lecture for the Esports Research Network lecture series. Today, we'll give you an overview of a few important things. Before we start introducing the project, we would like to tell you a bit more about our university, what we do in terms of esports and the local esports organization that we have in the city. Then Bram will tell more about the project, and I'll tell you a bit more about our future objectives and other esports research activities we have. Firstly, to shortly introduce ourselves, my name is Ekaterina, or in the gaming field, let's say, I am called Kvartau. I am from Breda University of Applied Sciences, the Academy for Games, Media and Artificial Intelligence, and I am currently working at the research and development team called Cradle as a project manager and producer. I'm also the division manager for the Counter-Strike teams at the Breda Guardians, and I do the esports research management for the Breda Guardians. I used to be also an esports lecturer for some courses at the Academy for Leisure and Events, but since recently I purely dedicated to project management and research. And Bram?
Oh, yeah. And I'm a lecturer applied data science and artificial intelligence, also at AGM, the Academy for AI Games and Media. And I'm specifically researching games and making methodology of how do we research games broader and how do we use that to improve game designs, performance, or team dynamics, and also teach AI students in that. And that's also what my PhD is about.
Firstly, shortly about our university. As we said, we are located in the Netherlands, in the city of Breda. We have several studies which are in some way linked to esports, let's say. We have the leisure and events management specialization called sports and esports, where you can specialize from the second year onwards. We have also a 6 months minor in esports events and media management. We have also a master in game technology, and Bram is lecturing for the Applied Data Science and Artificial Intelligence bachelor study. At the Breda University of Applied Sciences, we do have quite some labs and infrastructure to develop research and to do interesting experiment studies. We have, for example, the Experience Lab, where you can do measurements with using equipment like shimmers or empathicas. Bram will tell you about those later. We also have a motion capturing studio, a photogrammetry studio, an XR lab, and of course, we do have an esports space at the university called the Hive that I'll tell you more about. So the esports organization of the city of Breda, it's called Breda Guardians. It's been existing since about 2016, and since 4 years, around 4 years, we also have our own facility at the campus of Breda University. We do have currently about 6 teams which are participating in various competitions, mostly on national Dutch level. And we do have a base of 30 players from around 12 countries. We are very international, but also in our community, it's not only players who want to pursue esports more professionally in a team-based environment, but we do have a community of casual players as well. And Breda Guardians is run by 2 employees and 3 interns. In our esports facility called Hive, we do have 2 floors, where on the first floor we have space for shoutcasters, we have PCs for live streaming, we have Nintendo Switches, racing simulators, a PlayStation, while on the second floor it's our gaming area where you have 10 PCs, and anyone who is around can just come by and game for free. So if you're from the city of Breda or around, please come by. You can come by anytime. And we do have some esports research equipment, such as both software and hardware. Recently, we have purchased the Tobii Spark Pro eye tracker. We have new Anic rings, full HD stream cams, and stream lights. Now, before Bram tells you more about the esports project that we are running together, I would like to give you a bit of background about the, let's say, young people situation state of the art in the Netherlands, because that's what really motivated our project. We know that there's a lot of young people in the Netherlands, 2.6 million, and 77% of young people have a paid job. So if you look at those statistics compared to the EU, you can see that young people who are doing both education and working at the same time are really a majority in the Netherlands, and this majority is a lot bigger than in the other countries. So compared to the European average, we have 73%, while the EU is to only 25%, which means that we have a lot of young people who are very busy all the time, who are doing their studies, working a part-time job, which makes which can be quite a challenge if you're a young person and if you want to be competitive and if you want to participate at other activities. Um, so we can see that this also results in some issues like sleeping problems. For example, among young people, these have been increasing the past years, and the same goes for mental health issues. Um, and despite those statistics, we do have a lot of people in the Netherlands and in our city, Breda, who, despite being so busy, despite being so stressed all the time with studying, with working, with everything, they are also quite motivated to participate in esports activities. And we see that from the Breda Guardians teams. Majority of the people who join our teams are working students. So we do only accept students actually to join our teams in the Breda Guardians. And these students do this on a voluntary basis. So it's no contracts. We do not provide contracts. We do not provide payment. Students join by their own desire, by their own passion and motivation to be engaged with esports. So when we do recruitment for a team, for example, we really look not only at the level of skill of the how good they are at the game, of their motivation even, but we also look at their availability. If we objectively see together with the student that okay, you are way too busy, you cannot also have that. Of course, we will not say no, absolutely not, you cannot join, but we will warn them or we will try to support them the best way possible that this student does not go into a burnout situation. In that case, we try to manage expectation and priorities together, and we set up realistic goals with the team. And one important thing is that a lot of the cases for these teams are that there's no upper staff, let's say manager, coach, or even support staff. So a lot of the teams are self-managed. And the coaches, even if there are coaches or managers, a lot of the times those are also the students themselves. For CS, for the Counter-Strike division, for example, I did an exception because I am personally very engaged with esports, but we as employees as well, we did these are not our tasks. So we cannot have a full-time availability to do coaching to help those students. But they do deserve it because a lot of them are extremely motivated. A lot of them really want to reach the pro scene because, let's say, our student teams could be considered semi-professional teams in a sense that we do participate at official tournaments. Sometimes even we go to higher level tournaments as well. But to reach the pro scene, it takes more than that. But we are on entry level. Let's say they enter with us, they gain some experience playing in a team, and then they can go and start applying to those bigger and tier 2, let's say, or tier 1 teams, hopefully. And that's how we actually reach to the definition of what we want to do with the project, what we want to do with Bram and with the artificial intelligence department at the university, because we really saw this problem where we lack funds, capacity for dedicated coaching and managerial staff for our teams at the Breda Guardians. And we also have no tools to analyze or improve our performance as teams or as individuals who play in these teams. So coaching is done not as professionally as we would like to, and in that level of thinking, we reached to the point where with Bram we decided to set up a project together with Tilburg University as well, and as advisors, University of Twente and Han University of Applied Sciences, all Dutch universities, where we try to figure out a way with AI tools how we can help our teams enhance our performance. So I would now like to give Bram the stage to tell us more about this project.
Yeah, exactly. So most of the coaches they actually advise on based on a gut feeling, more than that they have some data-driven insights, and we really would like to have some action-to-action or moment-to-moment based metrics where where we can give feedback to the students to the players that this went wrong because of reason X, or here you did this, but you should rather do that this action, for example. And one of the advantages of recording data on in a game is that we can create a closed loop cognitive system regarding information flow. I'll tell a little bit more about that, but I can get all the data which the player sees, all the audiovisual data. I can register all the behavioral data, how they are moving in the game, how they move in the key and mouse board, and also what is going on inside of the player. And with that, we can take a more of a bottom-up approach. We can collect data en masse and build features using a data science approach. So at first, for example, specifying what reaction time would be or what efficient communication would be, we use a model to, for example, cluster or predict that state. And then we can take a bottom-up approach where we use all the data to create the future rather than that we define it and then statistically test it. And that also means that we need to have data of sufficient volume and quality to retrain or train ML models such as LLMs. These can provide the context to our data. And the advantage of course, esports players is that they train regularly and that they are high-performing individuals. So you have really high-quality data. And these industry problems, which Ekaterina just mentioned that Breda Guardian had, we also found them back when we were talking to actually professional teams. We were talking to coaches or assistant coaches or players at an international, regional, or European level. And from that qualitative research, we defined some KPIs, and from that we got some low-hanging fruits such as good communication, critical moments, reaction time to a stimuli. And then we started setting up our data collection with an initial focus of that high quality, high volume data collection, which means that we need to automate the data collection to get all these different modalities. Also, of course, if you're an esports player, you don't want to set up a lot of instruments in the beginning. You just want to press play and then that's it. And the data we want to collect is contextual data. That's the most important data stream because that defines on what is going on in the game environment. Who is winning, who is shooting who, what happened just before this moment went down, maybe a mistake was made, something went well. That's very important because then we can use that to predict with the other data streams. When something went right, for example, we can use how the player was moving or how they were shooting or what they were shooting on or how stressed they were to predict that. And that's where the behavioral data stream comes in. That really is all about logging what the player is doing and what the team is doing as an aggregate of that. Are they all moving towards the objective or are they still positioning? And the physiological data is mainly to see what is going on inside the player. Heart rate, skin conductivity, eye tracking, maybe even brain activity in the future. And with that, we essentially have that whole cognitive loop. So the player sees and hears the gameplay footage and sound, essentially. With that goes into the player, of course, and the brain processes it. Then we log the heart activity, the skin conductivity, the galvanic skin response, or that thermal activity. and the eye activities where they are looking at. Then we have an idea of what goes on inside the player. Is he stressed, panicky, happy, focused? And then that's translated into some kind of behavior. So in keyboard and mouse presses, into looking behavior, scanning on the map, for example. And that is then translated into game behavior, which is then again translated into gameplay data. And so the loop continues. And from these data streams, we're then going to engineer features such as efficient communication or reaction time, which we then display in a dashboard, mainly descriptive data to start with this initial phase.
Hello, I'm Bram Heijligers. I'm a setup of us where we can do.
Here you can see a quick demo of what we have
some
right
eye
now.
tracking. We also
capture
how people are actually communicating, how people are communicating in the game.
Yeah.
We're also taking physiological measurements. So this is micro sweat activity. We also are doing some heart activity measures. And one of the other things we do is the recognition of facial expressions and in extension to that, emotions, as you will see on screen now. Yeah.
Yeah, and then of course the control input and the mouse. I'll go a little bit more into detail of all the different components now. So one of the key things, of course, is to get the behavioral data, get the input, get the gameplay, get the control input. That means the mouse and the keyboard, or a controller if you're looking at a console, and the gameplay output. So the video and the audio stream, which is attached to the MP4 file of the video. You want to record that live. And that's really crucial contextual data, as I said. We need to know why the player is navigating in manner X, or why he's navigating towards that. Why did he press that button? It needs to make sense, all the other data streams. Then what we apply as well is eye tracking. So what the player is paying attention to, what is the most important thing to look at according to the player, or capturing their attention. And that can help us also identify what elements of the context are most important to the player, which is important for describing that with a large language model later. I'll go into that one a bit more. For that, we use the Tobii Pro Spark, which is the second best eye tracker in the world, scientific grade. It captures data at 60 Hertz, which is also the frequency at which we collect our time series data. And we track with that, we do eye tracking where somebody is looking at. Also pupil dilation and blink rate and duration are things we can measure from the player. Here's a quick demo again, where you can see how it works in the calibration stage. I'll show you in a bit how it works in theory. So here we have the relevant controls for Valorant, and we have the main menu, Valorant. The red circle is where the player is looking at. And then you can very easily see, what the player is looking at. The player will not see the red circle when he is actually playing. He'll only see his normal screen. We can see, as the analyst, we can see this when we are looking into our dashboard. We see the control inputs on the side. And we see also some other metrics. That's essentially how it looks. That will be very useful if you identify a critical moment, for example. Then you can see what the player is looking at. And from that, we also do some analysis. Some basic clustering analysis was done. K means clustering, to cluster, for example, different looking behaviors such as map awareness, checking the status of the game, scanning for enemies or objects, aiming, monitoring the ability, or looking at takedowns. And really, we define some region of interests, essentially. But this is just the start of our modeling. As I said, we mainly focus on setting up the data collection first. And in some next steps, we want to analyze the behavioral sequence. So maybe the player first does scan, then he is aiming, then he's shooting, then he looks at the takedown confirm, and that sequence of actions may have high predictive power to some mistake or critical moment occurring or happening, or a mistake happening. So that would be the next step with that. Then we also do have the Logitech StreamCam webcam. We use that also a bit for eye tracking. So we have a second measure, but mainly to analyze the facial expressions. So what we look at is different points on the face, which are then translated into action units, which are then aggregated to facial expressions. And that is then again aggregated to emotions. We can use all these 4 levels as input for our models. It's also captured at 60 hertz. We only save the dots for now because of ethical concerns. We might also store a video cut out of the face later. And we also control the lighting condition. Before I talk about that, we also need to note that depending on the culture or the person, emotions might differ. So that's why we also need to look at the lower level data streams. Because somebody, for example, the Dutch Prime Minister, he smiles very weirdly, for example, when he's angry. So then, for example, using traditional emotions to classify is not a great method of classifying emotions. Here you can see it in action, live. And then what we also use, of course, we also need to control the lighting conditions. So we have optimal performance of the models, both for eye tracking and the facial expressions analysis. For that, we have the 300 lux target brightness and the 4,000 to 5,000 Kelvin target warmth. It's also positioned frontally as much as possible, so the light rays bouncing are going as straight as possible. And then when we combine emotions and gaze data, this is roughly what you get. Currently, this person is looking very focused. We only have 6 emotional states currently as classified, but we need to move to 22 sometime soon. But there you could see it, where the player is looking at and what emotional state they have. What we then also get to get a little bit more insight into the player is physiological data, mainly to capture the state, capture certain events or changes in the player. We want to see what emotional arousal level they have. Are they experiencing stress? And for that, we are considering 3 devices, the mnemonic rings, the Shimmer 3 GSR, and the Batica 2, which is excluded for now. And we're then looking mainly at micro sweat activity and heart activity data, such as intermediate interval or heart rate variability. We're still making a final selection. Some devices are very intrusive, are a bit too intrusive. Some are very non-intrusive, but are difficult to program, to automate specifically, and synchronize that. So this is still an ongoing search. We're also considering maybe an esports sleeve or an infrared camera, which can also help work. The Shimmer 3 GSR is one of our main candidates, though. It's very good and very precise, although it is a bit more invasive and a little bit more difficult to set up, right? When you're playing, you ideally don't want to have these electrodes there. There are ways to set them up less intrusive, but then they're less precise. The mnemonic ring is better than that, and it does electrodermal activity very well. However, and accelerometry. However, it's a bit more difficult to set up and automate the data collection of. So this new semester, we're going to look into automating that. But that's roughly where we are now. Then what we also do, of course, as I mentioned before, we also capture the voice from the MP4 file that's done with OBS. And then we extract the audio from that, and then we chunk that into different sizes, 15, 30, and 60 seconds. Then we all translate that and triangulate the outcomes of that data. We translate the voice to text with Whisper, an OpenAI model, the medium model, or the V3 Turbo model is now also being considered. And we have a dictionary of all the relevant terms for that game, say like a call out or flash. These are all game specific terms, and the dictionary function also allows us to go switch, for example, to League of Legends or Rocket League, for example. And what we mainly are interested with this is the communication, especially during critical moments, because that's where often the esports coaches, the professionals indicate where things went wrong. And we did some initial modeling, although synchronization and windowing is still something we need to look into a bit more. But what we essentially did is we wanted to classify the communication efficiency, which is rule-based. We have certain effective types of communication which were predefined by the players and the coaches, by experts, which are targeting the objective, call-outs, abilities, maps, things related to navigation. Also neutral things, mentioning things of agents or items, and ineffective communication. And we saw that the majority of the communication was indeed effective, but there was also some neutral communication or ineffective communication. Examples of this is, for example, using the term clove or main, that is referring to an agent and is a call out. So this specific character is at a given location at this moment. Or miscellaneous communication, somebody just calling somebody a name, or we can have a combination of that, where we have people talking about the objectives, calling something out, but also making a reference, using some slang. And based on that, we can, and apart from that, we also let the experts, so the professional coaches and players, define different gameplay phases. We let them label them. Critical moments, execution, the planning phases, post-game, and positioning and map control. And here you can see a distribution of those different moments. So for example, in the beginning, we had a lot of critical moments, and at the end again. In the beginning, you might also see a bit more positioning. Oh, sorry, misinterpreted that. In the beginning, you see a lot of more positioning, and then later you see much more critical moments appearing, culminating at the end. And the idea is that you could also zoom into these moments in the dashboard and use the video and eye tracking. I'll go into that in a bit. Then we plotted the effective communication over the critical moments, where we could see how effective players were communicating or not during the critical moment. And then what we mainly saw is that people were mainly communicating efficiently during the critical moments, but there were some ineffective and neutral communications as well. And using this data and some other data streams, we tried to, as a preliminary prototype model, already predict those critical moments. And that already gave some nice results. So we tried two machine learning models, basic models, a random forest and a naive Bayes. We got already a 67% accuracy on the random forest with a very low sample, which is quite promising. And we think that if we gather more and more data, this should very nicely scale. Then here you can see some examples of the predicted moments. So we had a critical moment in the gameplay phase, and the communication was effective. They said they would go use some kind of mechanic on the other team. They were communicating about resources if they had their ultimate. But we can also see some examples of falsely predicted critical moments, or critical moments which were correctly predicted, but where communication was ineffective. So here he said that he's going to flash somebody, but then wasn't specific enough on what he could save another ability for. And some ineffective communication about just him reflecting, which isn't very useful for decision-making capabilities. So this is some initial modeling that we did, but we are also still facing some challenges. So we want to not just get contextual data out audio-visual data, which we would do with a large language model that would work as a shoutcaster, as it were. I'll tell you a little bit more about that. But we also want to get data from the Riot API, specifically also to combine those data streams, because it gives much higher reliability and robustness. For example, when was a player at which given exact coordinates, and where was the player looking at, when was a kill exactly made. That also helps with synchronizing and windowing with the large language model annotations. Of course, we want to engineer more KPIs, specifically more complex KPIs, refine the KPIs. All of this is, of course, preliminary. Also get more physiological data in. We really need to find a good balance with invasiveness and user-friendliness with robustness. So that is difficult, right? Brain activity, measuring that, putting something on with a headset gives a lot of noise. It's cumbersome. So we have to find a good balance with that. Also, time investment. These things just need a lot of time. Now we've been working on them for 20 weeks. And yeah, more time is just needed. And the other open challenge is the large language modulation and flagging of the events. So when is a mistake being made? When is something going right? A large language model like a shoutcaster is a really nice way to annotate whatever gameplay data we can see. And there's also a rich bed of training data for that, because of course there are a lot of shoutcasters or commentators commenting on the matches which are played by pros. And these very adequate descriptions, or mainly adequate descriptions of what happens in the game, are very nice targets or variables to predict with all the other data streams. And we also want to triangulate a bit more. So, for example, instead of just getting emotional states from the facial expressions, we want to also get it from voice, intonation, speed, positivity. We also want to do a sentiment analysis of the text itself, so the meaning of the words itself. And then we can combine the confidence of these scores. Also, of course, looking into different facial expressions or sentiment analysis models. So, for example, for facial expressions, we're already using OpenFace and PyFace, two models to get the score for the emotions, and then we aggregate the classification, the score, to get the highest possible confidence in a lean way. And here is a short demo of how it looks like from a player's perspective to use the toolkit. So here the bat file is just installed and it's launched. It's like executable. It's automatically setting everything up, loading the calibration player profile of the player. There it's snapped into place. You can see the emotions and some of the eye tracking from the top side. The scientific eye tracker is on the bottom of the screen of the monitor. That is the main output for the gaze data. As you can see, League has a much wider range of keyboard keys being used than Valorant, for example, or Counter-Strike. And afterwards, you just sign in with your game name and the game that you are playing. And then that's automatically warehoused into the into the data lake. Yeah, that's it. And there you also saw of course, the emotion script. And here, this is the dashboard. So, for example, if you have a critical moment, you can click on that moment, and then the dashboard toggles to that, snaps to that specific moment in time. So what we are going to do is initially just get from one player the footage and let the shoutcaster or commentator and LNM shoutcast and annotate on that, the full screen image. But we might also get the eye tracked exam. So you saw the circle on screen, and we might only get, say, like a 30-degree angle of that cutout, and use the part of the video which is most interesting to the player, apparently, to annotate what is going on. Or maybe We will combine both because with transformer models, the models where LLMs are based on, you can have multiple heads, multiple data streams, multiple things which are important to pay attention to describe what's going on in the game. And we can actually also not do this for one player, but we can do this for multiple players. So we can actually aggregate them and all insert them as separate heads, or feed both their full screen data and their eye tracking data, along also with their audio data, to annotate what is happening in real time. So we can get a measure of what the team is actually doing as well. And since they're already predicting essentially the next the LLM is predicting what to say, we can also actually use that for some predictive modeling. So predicting actually what is going to happen next in an interpretable manner, because the LLM would describe that in words what might happen next. And we are currently considering Llama, but we also have funding to use tokens for example, OpenAI, which is also being considered. But Llama is free and inexpensive computationally, so and there, of course, are quite some caveats, which I don't have time to go into now. So now we have already set up the toolkit. We started the data collection. We have the first iteration of the toolkit. Descriptive modeling is now done. And we're going to conduct some user studies now, engineer some more features, do a little bit more modeling also with our partner universities. And we set up some tutorials and workshops on how to use the toolkit. And then also have some academic outputs in terms of papers. And yeah.
And we will not stop there, of course. We would like to expand and, for example, we would like to assess the tool's usability for teams and players in the long run. So we will try to do some tests in the future once we have a fully developed tool. We would like to also inspire others to develop new AI applications in esports analytics. We can provide our toolkit to use as a backbone, all of the infrastructure that we have used. And we would like to also do tool knowledge transfer and applicability to other domains. And in the end, of course, develop the full data-driven AI coach. In terms of networking, we would like to foster also larger scale esports collaborations through the Esports Research Network, for example. We would like to engage more with industry partners and scale the tool to professional esports teams. And of course, we would like to increase the interest of young people in artificial intelligence and esports research.